continue on. So this here is a sideways parabola. So it's the negative y, x equal negative y squared. So backwards or this way facing, right? But I'm going to shift it up by 5. So that's what the parabola looks like. And then x equal 4 looks like this. So here's my area bounded. So you can see I have to do sideways rectangles. So I'm going to remember to put my dy down, because again, I cannot use rectangles going up and down because they touch the same function, top and bottom. So my area will be top, which is the purple function. So 5 minus y squared. Subtract off the red, which is the 4. So then I'm going to find out where they intersect. So 5 minus y squared is equal to 4. So 1 is y squared. So from negative 1 to 1. All right, so now let's look at this next one. So x equal y squared minus 3. So upward facing parabola shifted down by 3. And then this one would be downward facing parabola going up 3. Looks like that. Okay, so there's my area bounded. And so then if I'm going to have to draw the rectangles parallel like that, I'm sorry, sideways like that, so I'm going to do dy integration. So my area will be the top function, which is the purple, right? The top function is 3 minus y squared. Subtract off the blue function, which is y squared minus 3. And all of that is in the integral. And now I'm going to set them equal to each other. So 3 minus y squared is y squared minus 3. So I get 2y squared is equal to 6. And y squared is equal to 3. So plus or minus root 3. Okay. So I want to make sure that you're really getting good at this u substitution thing. So I'm letting u equal this inside, and the derivative of 3 to the x is 3 to the x times ln of 3. ln of 3 is a number, so I divide through by that number so that I can take out the 3 to the x and dx and put in a du over 3. And then I can replace the u in here, so don't forget the squared. It's really easy to forget the squared. So I'm going to take the time to put the ln of 3 outside, make that u to the negative 2, increase the exponent, so you get u to the negative 1 over 1, negative 1, and then put the x's back in. Again, if I'm going to be careful to spread it out, I'm going to let u equal that root x that's inside of the e. Take the derivative, which means you decrease the exponent, multiply by 2, so I can take this, oh, whoops, I made a mistake. This should be negative 1/2, right? Next to the negative 1/2 here, stays negative 1/2. So this gets taken out, and I get to put in a 2 and a du, right? Take out x to the negative 1/2 dx and put in 2 du. And then I can take and put e to the u, right? E to the u. Antiderivative of e to the u is e to the u. Carry the 2. And so then I just got to put the x's back in. So take note of that typo there. Okay. So you know this. So now I'm giving you this. So if it's not just an 1, if it's an a, then you have to put the x over the a. So you know this already. You know this already. So now I'm adding it. If I have a squared plus x squared, I have a 1 over a on the outside and on the inside. So this one here would be inverse sine of x over 3 plus c. And then this one here, looking a lot like this. So be clever. And let's let u equal sine of x. du is cosine of x. Oh, look at that. So if I have 1 over the square root of 16 minus sine squared of x, and then cosine of x dx, then the cosine of x dx gets taken out and du gets put in, right? That gets taken out. Du gets put in. Integral sign carries along. And now I'm going to put in the 1 over square root of 16 minus u squared. So this is my arc sine. So it's, my arc sine does not have does not have a 1 over a in the front. So it's going to be arc sine of u over 4. And then I put the u back in. And the u is u is sine. Whoops, u is sine. So sine of x over 4 plus c. Okay, this is my new arctangent. So it's going to be a 1/2 on the outside. Arctangent of x over 2, because 4 is the 2 squared. This one here, I'm going to be clever and let u equal e to the x. So e to the x dx is my numerator. So again, if I split it up a little bit, then I can see if I put this u, right? Oops, let's put this u in for this. So I'd have 25 plus u squared, because that's e to the x squared. And then I can take out e to the x dx and put in du. Now I can see it's the arctangent. And I'd get u over 5, and then make sure you do the last step, arctangent of e to the x over 5 plus c.